but I'm going to record it. So I'm going to then upload it onto YouTube so you can find it again later on. So you can watch it on that screen, you can watch it on the screen, but I'm going to be writing on the screen. So you're completing the square. You did everything right. You just, when you did, you didn't square the 3/2.
Oh, okay.
That's the only problem you had. But we'll go from the start because that way you can see it. So we've got x squared minus 3x, and you're correct. You are putting the 10 over the other side. So you're adding 10 to both sides.
Yep.
Normally I'd write it sort of underneath for those who are just starting out, but I won't do it now. You cool?
Mm-hmm.
So we've added 10 to both sides. Cool. And then you're completing the square, so you've got to go, okay, what do I need to add on to the end to complete this square, to make this left-hand side the possibility of being a perfect square? And you were absolutely right, x squared minus 3x, and then the square of half of that. So you halve it and square it. So that would be plus 3/2 squared. And now the idea of not actually squaring it out is fine, because you're going to be square rooting it again in a second anyway. Okay, so leave it like that. It's nice and easy. You've got to square at the front, you've got to square at the end, you're happy. Cool. But we've added it to that side, so we need to add it to this side as well. Okay, and we'll leave it as that. Now this side we are going to expand, because otherwise we've got a 10 there and trying to find the square root of 10 plus 3/2. No, it's not. It's not pretty. Okay, so we're now going to factorise this one, and you've made it a perfect square. That's the whole point. So you end up with x minus 3/2 squared. Cool? You happy with that?
3 go?
The 3's still sitting there. Which 3 do you mean? The 3?
The 3 right after the x squared.
The one that is the coefficient of x?
Yeah.
Okay, remember when you expand it out, you're going to be squaring the first, you're going to be doubling the product of the 2 inside the brackets. So the product of those 2 would be 3/2 on minus 3/2x, correct? If you multiply those two terms,
3 minus 3 over x.
You're going to end up with minus 3/2 times x.
Yeah.
Because that's the product. And then you double that, and it'll end up being minus 3x. Okay. So this is just the factorisation of that. Yeah? So square root of the first, square root of the last. Cool. With the minus in there because we've got a minus there. You remember that?
Kind of.
Okay. Well, let's just expand that one out then. We'll go over here. And we'll go, okay, let's expand that out. So we've got to do first by first, if you're going to do it the long way. Or do you remember how to do expansion of perfect squares the short way? You wrote it down in the book when I told you on Tuesday. In fact, it's in red at the top of that right-hand page.
Square the first, double all the product, square the last.
Okay, so square the first. So x squared is? X squared.
Yeah.
Okay, double the product. So we're doing plus 2 times, because that's the double, the product of x times minus 3 on 2. Cool?
Yeah.
And then we square the last. So minus 3 on 2 squared is going to be plus 3 on 2 squared. Cool? Because it's going to be positive. So I should actually put that minus, just so for the sake of accuracy. Oh, come on, work with me here, computer. For the sake of accuracy. Okay, for some reason, every now and then, oh, it's working again. Why are you not erasing me? There we go. For the sake of accuracy, I should put minus 3 on 2 squared, because that's what you're squaring. Cool?
Yeah.
Now, if I do that, we've got the x squared, we've got the plus 3 on 2 squared, which we've got up here.
Mm-hmm.
Okay, so that's all good. Now, x times minus 3 on 2 is minus 3 on 2x, right?
Yeah.
Okay, and 2 times minus 3 on 2x.
6 on 4.
If you've got, so plus 2, oh, wow, you're being nasty, 2 times minus 3 on 2x.
Oh, negative 6 on 2.
What are the 2's going to do? You're multiplying fractions. So if I've got, you have done multiplying fractions. If I've got 2 times minus 3 on 2, what do I get?
Wouldn't it be negative 6 on 4?
No, it would not. Because if I did that, if I got minus 6 on 4, can I simplify that fraction?
No.
Yes, of course I can.
What?
It's got a common denominator, or a common factor.
2.
Yeah. So what would it simplify down to?
It would simplify down to 3 on 2.
Minus 3 on 2, which is what we started with.
Yeah.
Which means when you did it, you didn't change the fraction. That's exactly the same fraction as that, which means you multiplied it by 1.
Okay.
And how do I write? That is the equivalent of 1, isn't it? So when you multiplied it, you actually multiplied the numerator by 2 and the denominator by 2, which is the same as multiplying it by 1. Yeah?
Yeah.
But we don't do that. So what's the denominator when we've just got the number 2? What's the denominator?
0? 1?
No, you can't divide by 0.
1?
Correct. So now, do what you were doing. Multiply the numerator.
Negative 6 on 2.
There we go. So that's what you get. Can you simplify that?
Yes.
And it simplifies down to?
Simplifies down to 3. Wait, no.
Yeah.
4 on 2.
No.
3 on 1.
Yeah, minus 3 on 1.
Minus 3.
Because 2 goes into that once, 2 goes into that minus 3 times.
Oh.
So
It is
that's
minus 3.
where your minus 3 goes. Okay? Because it is just double the product of that. Is that alright?
Kind of. Where'd you get the 1 go though?
What one?
Shouldn't there be a 1 under there?
Yeah, go for it. When do we write fractions like that? Or when do we write numbers like that?
Never.
Cool. We could actually write numbers like this. So here is a number. Let's call it 5. Okay, but I'll write it as a fraction. So it's 5 to the 5 over 1.
Oh, they're always 5 on 1.
Anything to itself. But we can also go, well, 5 is actually the same as 5 to the power of 1. Yeah?
Yeah.
But it's also
The same as.
the square root of 5 to the power of 1 squared.
So we
Divided
don't
by
write it all like that.
No, because we could keep adding it, and we could actually write, well, that's 1 times the square root of 5 to the power of 1 squared over 1. Okay, we can keep adding complexity to it,
But it just makes it
but
confusing.
1 times means it doesn't change. Okay, the square root and the squared cancel each other out. 5 to the power of 1 is just 5, and 5 over 1 is just 5.
Okay.
So we simplify it down. So
That makes sense.
it exists, same as there's a 1 in front of the x. There's always a coefficient, but if it's 1, we don't write it. Okay? We try and keep our complexity down. That make sense?
Yes, makes sense.
So, getting back to this, I'm going to get rid of this arrow because this was all just where our minus 3 had gone. Okay, so we now know where our minus 3 had gone? Yeah, so I'm just going to do that and just put a line through it. Not that it's wrong, it's just nothing to do with this.
Yeah.
No. So what we've done is we've added 10 to both sides, and then we can complete the square, which is going to be half of that squared. So I should actually, once again, to be precise, I should have a minus in there and a minus in there. But because you're squaring it, they come out as positives anyway. Okay? But it is minus 3 on 2 squared. Okay, so we've done that to both sides. When we factorize that, because we've made that a perfect square, this is the factorized version of the perfect square. Okay, so we've now got that, and you can see if we expanded it, we get to the right things. Now, we've got this. Now, we know in the next step we're going to square root this and end up with, well, that's me pressing buttons, x minus 3 on 2. Okay, that's what we're going to end up with because we're going to square root it. Now, we're going to have to square root the right-hand side as well. But at the moment, it's in a form that's not very pretty for square root. Let's convert it so that it's going to be a much nicer number. So, when I square this, minus 3 on 2 squared is actually 9 on 4. Okay? Because squaring is just multiplying by itself.
So it's just that times itself.
Yep. Minus 3 times minus 3, 2 times 2. Okay? It gives you 9 on 4.
Yeah.
Okay? And then I'll convert this to quarters as well, because it just makes it a lot easier to add them together.
Oh.
Okay? So I've converted the 10 to quarters. In your one, when you did it,
10 on 1 and then it turns into...
correct, 40 on 4.
Yeah,
so when you did it, you didn't square this.
No.
You left it as 3 on 2.
Yeah.
Okay? So we now have 49 on 4. It's all right, you can write it down in a second. No, because I'm recording, remember? Everyone in the world is going to hear this.
Oh.
Well, when I say everyone in the world, people who watch it, so no one. So we square root both sides. So we get x minus 3 on 2. Yeah?
Yeah.
And then we square root that side. What's a square root? And this is lucky because 49 is a square number, 4 is a square number, which means we can find the square root of this fraction. What is the square root of 49 and 4? Square root of 49 is?
7.
Yes, it is. Square root of 4 is?
2.
Excellent. So we've got 7 over 2.
Yep.
All right. However, we've talked about this before. What's the square root of 4?
2.
No, it's not.
Square root.
Yeah, square root of 4. I shouldn't say no, it's not. That's not the full answer.
Negative 2.
Yeah, negative 2 is a good answer as well, but that's not the full answer.
2 and 1.
No. Positive and negative.
Oh.
They're both possibilities. So you have to have the positive and the negative.
That's the mistake I made in 11.
Yep. And remember, this is where we talked about, this is a quadratic. Its degree is 2.
Yeah.
It's degree, isn't it? Oh, let's get that wrong. Yeah, it's degrees 2, which means you've got a potential for up to 2 answers. Okay? So now we do both versions. So we go, okay, we've got x minus 3 equals 7 on 2. I've got x minus 3. Oh, sorry, x minus 3 on 2. Where am I going? Equals minus 7 on 2. Okay, so you got those two versions. Now you have to do it. So you add 3 on 2 to that side. So you get x equals 10 on 2. And you add 3 on 2 to that side, and you get
X equals minus 4
on 2. Because it's just, you're adding them. So that is 5, and that is minus 2. And there are your 2 answers.
Like 10 and minus 4 turns into 5 and minus 2.
10 over 2 turns into 5, and minus 4 over 2 turns into minus 2.
Yeah.
Yeah.
Okay.
Does that make sense?
Yes, that does actually.